Now, let us move on to the next problem, which goes like this. Find the position of the centroid of the plane lamina as shown in figure. With respect to O. So, in this problem they have given the reference point. Please observe with respect to O. So, let us see how it looks like. So, this is the lamina given. Now, let me write the axis which is specified. See, in this problem they have asked you to locate the centroid with respect to point O. So, this is the lamina which we have to locate the centroid. Okay. So, let me write the data or the dimensions. $75 112.5. This is 75, this is 80, and the radius of this semicircle is given as R, which is R equals to 56.25 mm. Okay. So, now if you observe, we need to determine or locate the centroid with respect to point O as shown in figure. According to this particular point, we need to locate the centroid. So, what is the first step? That is, look for the axis of symmetry, if any. Do you find any axis of symmetry here? No. Then second step is divide this into number of known components, or the second step will be writing the reference axis. Since the reference axis is already given, I did not mention it in second step. So, the second step will be dividing this lamina into number of known components. Okay. And now we shall divide the components and number the components. So, let me write A, B, C, D, E, F. I will not write G because it is used for centroid, and let this point be H, it is O, and I. So, these are the boundary points. So, just used for your convenience. Okay. For your convenience, we can name the boundaries. Okay. Now, let us divide. See the first component or the first triangle ABI portion, it is looking like a right angle triangle. So, let me name it as component 1, and we have this second component, again it looks like a triangle. So, let this be component 2. Now, the third component be this rectangle, component 3. Let the fourth component be this semicircle, which is component 4, and is the dividing of the components over or not? No. We have one more component here. See, this is the actual lamina which they have given. So, component 1 is a right angle triangle with the dimensions of 75 mm and 75 mm, and the sides are A, B and I, and we know to locate the centroid of a right angle triangle like this, x and y. Now, when we calculate the areas, A1 half into 75 into 75, which is equal to 2812.5 mm square. X component of this particular triangle is equal to base by 3 and y component of this triangle is equal to h by 3. So, this is component 1. Now, we shall go to component 2. Again it is a triangle, right angle triangle, and the base is 75 mm, the height is 112.5 mm, and the sides are I, B and H. So, do you know where to locate the center of this triangle? It is at this point. At what distance? We know it. It is x and it is y. There is A2 is equal to half into 75 into 112.5, which is equal to 4218.75 mm square, and the x component of this particular triangle is equal to b by 3, which is 25, and y component is equal to h by 3, is equal to 37.5 mm. This is x and y component of second component. Now, we shall calculate the areas x and y components of component 3, 4 and 5 respectively. Component 3, that is a rectangle B, C, F and H. This is 80 mm and this is 112.5 mm. So, now you know how to locate the centroid. Where does the centroid of this rectangular component lie? It is exactly at center. So, this will be its x component, this will be its y component. Now, we shall calculate its area. A3 is equal to 80 by 112.5 and x is equal to 80 by 2, which is equal to 40 mm, and y is equal to 112.5 by 2, which is equal to 66.25 mm. Okay. Similarly, component 3 is over now. Next we shall calculate component 4. The area is 9000 mm square. What is component 4? It is a semicircle. So, semicircle, let me write the sides C, D, F and E. What is the radius? It is given as 56.25 mm. And where does the centroid of a semicircle lie? We have already derived it. So, it lies exactly at this point, somewhere here. The y bar will be now equal to x bar, because the orientation of the semicircle is changed. So, this will be its x component and the y component will be 0, because it is symmetrical about this axis. I am talking only with respect to this component 4 only. I am not placing this here and measuring the centroid. I am only calculating the centroidal component of a semicircle individually. I am not measuring it with respect to the referral axis. So, this x is nothing but 4r by 3 pi. First, let me calculate its area A4. What is the area of semicircle? It is pi r square by 2. It is pi into 56.25 square by 2. This is equal to 4970.1 mm square, whereas this x component is 4r by 3 pi, which is 4 into 56.25 by 3 pi mm. There is no need to write y because it is 0. Y component of component number 4 is 0. But when you measure it with respect to the reference axis, that will not be equal to 0. Okay? Please be careful. So, component area in mm square, x bar in mm with respect to OY axis, y bar with respect to OX axis. So, component 1 is A, B and I. This is a right angle triangle and we have already calculated the area half into 75 into 75, which is equal to 2812.5 mm square, and x1 is equal to. So, try to locate the central component of component 1 and measure it with respect to the reference axis or the coordinate axis. This will be x1. So, it is nothing but b by 3. Now, what about y1? Y1 should be measured with respect to the reference axis. This is the y1 value. So, y1 is measured from this axis until this point. So, from this to this point we have 112.5 plus 75 by 3, that is h by 3 is equal to 112.5 plus 75 by 3, which is equal to 112.5 plus 25, which turns out to be 137.5 mm. So, this is a right angle triangle. Component 2, again it is a right angle triangle with I, B and H. So, what about its area? 4218.75 mm square, and x2. Locate the centroidal component of component 2 and measure it with respect to the reference axis. This is x2. But we had determined the centroidal value from this end, that is b by 3. But if you want to measure it from this end, it is 2b by 3, or you can write as 75 mm minus 75 by 3. Okay. So, that is x2 is equal to 75 minus 75 by 3, which is equal to 75 minus 25, which is equal to 50 mm. That is the distance from the OY axis. Next, y2, that is to be measured with respect to the OX axis. So, again we had initially calculated this distance, but you need to measure it from the other end, that will be y2, because it is the reference axis. So, the total height is 112.5. So, if you deduct 112.5 minus this value, you will be getting the y2 value, that is equal to 112.5 minus 112.5 by 3 is equal to 112.5 minus 37.5, which is equal to 75 mm. Component 2 is over. Component 3 is a rectangle BCFH. So, the area is 80 by 112.5, which is 9000 mm square, and the x3 value from OY axis. So, this is the centroid where the rectangle centroid will be lying. This is the point. So, you have to measure it from this end. So, this is nothing but x3. So, we had determined this distance initially. Now, add that with respect to OY axis. So, from here to here it is 75, and it should be 75 plus 80 by 2. Which is equal to 75 plus 40, which is 115 mm x3. Now, coming to y3, measure it with respect to OX. So, it exactly can be written as half of 112.5. $66.25. Let us go with component 4, CEF, semicircle, and the area of this semicircle is 4970.1. What about its x component? x4, that is x4 is equal to it should be measured from the referral axis. So, it should be along this line. So, from here to here is x4. Okay. Now, if this is x4, we know this distance already, which is already calculated, that is 4r by 3 pi. Now you have to measure it from OY, that is 75 plus 80 plus 4r by 3 pi. 75 mm plus 80 plus 4 into 56.25 by 3 pi, which is equal to 178.87. And y4, that is measure the distance with respect to O x axis, and this is y4. If you look at the figure, you can easily say that this is equal to nothing but the radius. Okay. So, here y4 is equal to radius r is equal to 56.25 mm. Now, we had already mentioned this opening part as component phi. Now, please look into the picture and think about whether you need to deduct this area or you can just leave it off. Why I had written it as number 5? Because I wanted you people to think about it. So, this component phi is completely lying outside this lamina. Therefore, it will not cause any effect with respect to the location of the centroid of this lamina, which is shown in figure. So, this component phi is not at all required. If there was an opening made inside, then you can have easily chosen that particular component also. But since it is outside the component and it is not at all required, we should not consider this portion by writing it with a negative sign. We can eliminate that. Okay? There is no necessity to write this as component phi, not at all required. So, let me erase this, because it will not have any effect with respect to the location of the centroid. So, this is our table. So, if you have the values of x1, y1, x2, y2, x3, y3 and x4, y4, you can now easily calculate what is the x bar and y bar of the entire lamina. Okay. So, that we can calculate using the formulas. Okay. So, for that, let me erase the first two columns, because I need these values to be substituted. So, x bar is equal to a1 x1 plus a2 x2 plus a3 x3 plus a4 x4 divided by a1 plus a2 plus a3 plus a4, which is equal to x bar is equal to what is a1, 2812.5 into 25 plus a2 4218.75 let me erase this as well. I will write the values. Into x2 50 plus a3 9000 into x3 115 plus a4 4970 into y4 sorry x4 178.87 whole divided by 2812.5 plus 4218.75 plus 9000 plus 4970.1, which is equal to 105 mm, which is x bar. Similarly, we can also calculate y bar, which is given as a1 y1 plus a2 y2 plus a3 y3 plus a4 y4 whole divided by a1 plus a2 plus a3 plus a4, which is equal to 2812.5 into y1 137.5 plus a2 4218.75 into y2 75 plus 9000 into y3 56.25, sorry, so now let us calculate x bar and y bar. That is, x bar is equal to a1 x1 plus a2 x2 plus a3 x3 plus a4 x4 whole divided by a1 plus a2 plus a3 plus a4. So, after you substitute a1 x1 a2 a2 x2 a3 x3 and a4 x4 from the table, you get x bar as equal to 105 mm. Similarly, when you substitute y bar as a1 y1 plus a2 y2 plus a3 y3 plus a4 y4 whole divided by a1 plus a2 plus a3 plus a4, you are going to get the y bar as 70.9 mm. I hope you have understood this problem. Now, let us continue with the next problem, which goes like this. Determine the position of the centroid for the lamina with a circular cutout. Shown in figure. So, in this problem, they have given a circular cutout to the existing lamina. Let us see how it looks. this is the lamina which they have given, and this is the cutout to be made, circular cutout, and this is the actual lamina given, which is this entire figure, out of which you have to remove this portion. Okay. So, now let us write the dimensions which is given. mm, this is 60 mm, this is 60 mm, and the radius is given as 50 mm. Radius of the semicircle is 50 mm, and the radius of the circle is given as 20 mm. Okay. So, this is the shape that they have given. Now, if you do not differentiate the cutout and this lamina, it will be very much difficult for you to cut this particular circle. So, for that what I will be doing is, I will be shading the entire lamina without shading this circular region, because it is the region that has to be removed. So, what I will be doing is, I will shade the region. Okay. So, this is the lamina whose centroid has to be located with this circular opening. Now, the usual steps are, find any axis of symmetry. Is it possible here? No, it is not. Then write the reference axis. I have already written the reference axis. Then divide the composite section into known components. If you divide these unknown components into known components, then we can easily write the component numbers. So, I shall start numbering. So, this will be, say, A, B, C, D, E, and then F and O, and this center be, say, H. Okay. So, the first component will be, it is already divided, it is triangle section 1, ABF, triangle ABF. Second section, let that be the rectangular section, second section be the rectangle, and third section be this semicircle. Semicircle be the third section or the third component, and the fourth component be the circle. This is H, not 4, and this shall be the fourth component whose area has to be removed out. That is, the area should be written with a negative sign. Clear? Component 1 is a right angle triangle which is A, B and F. The height is 60 mm and the base is 120 mm. And where does the centroid lie for a rectangle triangle? It is here. So, this is our x component of this triangle and this will be the y component of the triangle. So, if I write the area A1, it is half into base into height. Okay. That is equal to 3600 mm square. This is A1. Next, x component is equal to base by 3, 120 by 3, which is equal to 40 mm. Y component is equal to h by 3, 60 by 3, which is equal to 20 mm. Next, component 2. So, it is a rectangle of size 120 mm by 100 mm F B D O. How is it 100 mm? See, if this is the radius given as 50, this also will be equal to 50. So, 50 plus 50 is nothing but 100. Okay. So, the centroid of this rectangle lies exactly at center. So, this is the x component of the rectangle, this will be the y component of the rectangle. Now, if you write the area A2 120 by 100, which is 12,000 mm square, x component is equal to half of 120 60 mm and y component is equal to 100 by 2, which is equal to 50 mm. Now, we shall calculate the areas of component 3 and 4. So, component 3 is our semicircle. B, C, D and E. So, now the radius is given as 50 mm. So, this will be also equal to 50 mm. Now, where does the centroid of this semicircle lie? It will lying along this particular line. Again, the orientation of the semicircle is now changed. So, this will be equal to x component, which will be equal to 4r by 3 pi. Here y bar is absent, y component of this is 0 because it is symmetrical about this axis. Okay. Now, if I write the area, A3 is equal to pi r square by 2, which is pi into 50 square by 2. Okay. So, let it be as it is, we shall substitute at the end, and then the x value is nothing but 4 r by 3 pi, which is 4 into 50 by 3 pi. So, this shall also be as it is, we shall substitute it in the same manner. And at last, the component 4. Why am I not writing y component here? Because y component for this individual section is 0 because it is symmetrical about the same axis. Okay? Because it is symmetrical about this axis, there will be no y bar. Then component 4 is the circle, with the h being the center and the radius being 20 mm. Now, this area needs to be removed out. Now, what about the centroidal component? Where exactly does the centroid of a circle lie? It exactly lies at the center. So, if the radius is 20, what about this x component? It is also 20, and what about the y component? It will also be equal to 20 mm. And the area of component 4 is equal to pi r square, but with a negative sign. Why? Because it is the cutout, it has to be removed. So, this shall be equal to pi into 50 square, but is with the minus sign. Then x component of this is 20 mm, it is equal to radius, y component is equal to radius, which is equal to 20 mm. Be careful with the sign, you have to write the negative sign only for the area. If you measure the x and y components with respect to the coordinate axis or the referral axis, take the signs correspondingly. Okay. So, now let us write the same details in the tabular form. Now, we shall write the same details in the tabular form, and let us measure the centroidal distance from the reference axis or the coordinate axis. So, the first column will be component the second column will be area, and that is in mm square. The third column is in mm, which is x bar with respect to OY axis, and the y bar is measured with respect to OX axis. So, this is the component 1. Component 1 is this right angle triangle A, B and F. Then the area half into base 120 into height 60, which is nothing but A1, which is equal to 3600 mm square, and x1 is to be measured from the OY axis. So, this is x1, which is nothing but base by 3, which we already determined, which is 120 by 3, which is equal to 40 mm. Now, coming to y1, measure the same distance with respect to OX axis, which is y1. We had determined this distance, which is h by 3. If you measure it with respect to OX axis, you have to add 100 mm plus h by 3. H is 60 by 3, which is equal to 120 mm. Y1 is over. Second component is the rectangular component FBDO, and its area is A2, which is 120 by 100, which is equal to 12,000 mm square, and its x2 is given by. So, where does the centroid of the rectangle lie? Exactly at center. So, what about this distance? That is nothing but x2. So, we can easily see that the centroid of this rectangle exactly lies at center, which is equal to 60 mm, and y2 is equal to, so this distance. Again we can easily say from this figure it is equal to 50 mm, which is this width. And next, the third component is the semicircle BCDE. Now, x3 to be measured from OY axis. So, we know the centroid lies here. This distance is nothing but x3. We know only this part, which is nothing but 4r by 3 pi, but we measure it from this end, it will be 120 plus 4r by 3 pi. So, I will be writing x3 as 120 plus 4 into 50 by 3 pi. I had skipped calculating the area, that is A3 equals to pi r square by 2, which is pi into 50 square by 2. Let it be as it is, we shall substitute it later. And then y3 is equal to, with respect to OX axis to the same point, measure this as y3. So, you can easily say it is 50 mm. At last, the fourth and the last component is circle. So, area of the circle A4 with a minus sign pi into r square, which is minus pi into 50 square. Now, writing its x4 and y4 values. x4 is equal to, measured with respect to OY axis. This is x4. Again you can easily say it is equal to 60 mm, and y4, if you observe the figure clearly, again it will be equal to 50 mm. See, the same distance is also our y4. Now we have calculated all the values of x1, y1, x2, y2, x3, y3, x4, y4 in order to calculate x bar and y bar, that is measured from OY axis and OX axis. In the next step, you need to take these values and substitute in x bar and y bar formulas. So, let me write the final answer. Is x bar is equal to a1 x1 plus a2 x2 plus a3 x3 plus a4 x4. You know why I am writing plus at the last? a1 plus a2 plus a3 plus a4. We know that a4 should be substituted with a minus sign, but even that I am writing the plus sign here because we shall not change the formula. You might be having little bit confusion if you write minus sign here. If you write minus here again, write minus here, it will be plus again. So, substitute the value as it is with a negative sign. So, that turns out to be a1 x1 plus a2 x2 plus a3 x3 plus of minus a4 x4 whole divided by a1 plus a2 plus a3 plus of minus a4. This is equal to, after substitution, 73.52 mm. Similarly, if you calculate y bar, that will be equal to 63.8 mm. See, once you are done with calculation of x bar and y bar, please write the last step, which is g of x bar comma y bar is equal to 73.52 comma 63.8 mm. Now, try to locate this in this diagram. So, x is 73.52. So, it is 60, 73 somewhere lies here and 63.8. So, this is 50, 63.8 somewhere here. So, this is the centroid of the entire lamina including this cutout section. So, this is our G. Let me draw the centroidal axis XX and YY.